Hi guys, this is experimental chemistry and we are looking at apparatus commonly found in a chemistry lab and their uses. So when we are going to a chemistry lab to perform certain experiments, the key knowledge that we need to acquire before we start our experiments is the availability of the apparatus in the lab and their uses. For example, if we need to measure volume of chemicals, so there are multiple apparatus available and they are used for different purposes. Not all apparatus can be used for measuring volumes under different circumstances. So let us begin with looking at the different apparatus that is available in the lab for measuring volumes and how and where it will be used. The very first apparatus that we are going to be looking at is a burette. A burette is a chemistry apparatus that is used for measuring accurate volumes. Now, suppose we need to measure 10 centimeter cube. So there are multiple apparatus available in the lab for measuring 10 centimeter cube of a solution. A burette is one of them. However, a burette can also be used to measure 10.1 and 10.2 centimeter cube volumes, which makes it an apparatus that is used to measure accurate volumes, which are variable. And this is not the case with certain other apparatus used for measuring volume. So a burette will be used for measuring variable volumes accurately. So when we measure volumes using a burette, the first thing we need to know is that the burette is starting at the point 0, and as we use up the solution in the burette, the volume goes down and the readings increase. So 0, 10, 20, 30, 40, and 50 are displayed. However, what is not displayed is the fact that a burette has a volume of 50 cm cube, not from where the 50 mark is placed. However, we need to know that it starts from the bottom of the burette where you can see the tap. This is the tap of the burette. And if we open the tap, the solution starts pouring out from the nozzle. So when we start filling up a burette, the burette needs to be start filling up from the nozzle upwards so that the volume filled up till the 0 mark would be 50 cm cube. So this is something that is not marked on the burette, but we need to be aware of this fact. So measuring 50 cm cube using a burette would be going from 0 till the tap. However, we do not take any volume from 50 below. This is just there to make sure that we can measure 50 cm cube using this burette. So if we need to measure 50 cm cube, we start from the 0 mark and we go right up till the 50 mark. We do not go below that when measuring the volume, as in we take the solution from the burette. However, when we fill the burette, we start from the bottom of the tap right up till the 0 mark. Now, in order to measure the volume at the 0 mark or any other mark, we need to know that the liquid that is contained in the burette has a meniscus present on it. So on the right, you can see meniscus labeled. There are two meniscus that you can see. This one is called the lower meniscus. Lower meniscus, and the lower meniscus is usually used when the solution that we are using is clear or transparent. So if we need to fill it up till the 0 mark, the lower meniscus of the clear or transparent liquid must be placed at the 0 mark. Certain liquids like KMNO4, which are purple in color, are very difficult to measure with the lower meniscus because the color that the liquids have is quite deep. So for such liquids, we use the upper meniscus. Here, this is the upper meniscus that I have just marked. And for solutions that are deeply colored, we use the upper meniscus to measure volumes. Meaning, if we need to place the value at 0, the upper meniscus would be placed at 0. Another thing we need to remember is that we need to see the volume of the liquid at eye level. We do not need to place the burette below the eye level or above the eye level, because that would create a parallax error, and parallax error is basically human error. So we can easily avoid that by measuring the volume by placing the burette at our eye level. So now that we have filled the burette up with a solution, we need to take, for example, 12.3 centimeter cube of the liquid from the burette. So we need to measure the burette twice. First, we will measure the initial volume, and the initial volume has been set at 0 centimeter cube. We write it as 0.00 cm cube because volumes are recorded to two decimal places. Then we take out 12.3 centimeter cube, and which will be written as 12.30 centimeter cube, and this is known as the final volume. So as you can see, we read the burette twice before we actually write down the volume that we have taken from the burette. So volume used will be equal to final minus initial volume. So that would give us 12.30 minus 0.00, which is equal to 12.30 cm cube that we measured from our burette. Now, if we need to take out another measurement of volume from the same burette. So now the initial value has been placed at 12.30 because that much liquid was taken out of the burette in the first go. And then we measured it till 25.00 cm cube. So now, in order to measure the volume used, we will subtract 12.30 from 25.00 and end up with 12.70 cm cube of liquid being taken in the second go. And that is how a burette is used. So the volumes that we take from a burette can be measured at zero point 0.1 centimeter cube because that is the least count of the burette. Least count is 0.10 cm cube. Another thing we need to know is why we keep mentioning a 2 dp value for volume. So a burette is an apparatus that may have errors, and it does. In fact, all apparatus used in a chemistry lab has errors. So the error in reading a burette volume using a burette would be half of least count. So error is equal to half of least count. And since the least count is 0.10, the error would be 0.10 divided by 2, which will be 0.05 centimeter cube. So since here the error is read to 2 dp, that is why we record all volumes to 2 dp. So if we need to put down the error would be written as plus minus 0.05 centimeter cube. The reason is, if we have an error of 0.05 cm cube, it could either be in the positive direction or in the negative direction. That means if we have recorded a value of 12.70 cm cube in the second reading, for example, so the error for the volumes recorded can be 12.70. So this is the error in the negative region. So that would be 12.70 minus 0.05, which is equal to 12.65 centimeter cube. This is the lowest volume that we have taken out. And if the error is in the positive region, then we would add 12.70 to 0.05, and the volume that we measured is 12.75 centimeter cube. This means that the reading that we took as 12.70 cm cube may lie between 12.65 cm cube and 12.75 cm cube based on the reading, the error reading of the burette. However, this is also not true because we have read the burette twice. So because we have read the burette twice, this error is for a single reading, and we by reading the burette twice, the error is multiplied by 2. So instead of the error being 12.65 and 12.75, we do not subtract 0.05 from 12.70, rather the error in a single Burette reading. So error in a single Burette reading would be 0.05 into 2, and this is equal to 0.10 cm cube. So instead of subtracting 0.05 from 12.70, it would be 12.70 minus 0.10, which gives us the least value for volume as 12.60 cm cube. And in the positive scale, we have 12.70 plus 0.10, which is equal to 12.80 cm cube. So the reading that we have taken lies in the range of 12.60 cm cube and 12.80 cm cube, considering the error in a single Burette reading because the Burette is read twice. So the error in uh, uh, reading from the Burette is 0.05 cm cube. The error in taking a single reading is 0.05 into 2 because we read the Burette for initial volume, which gives us an error of 0.05, and we read it for the final volume, which gives us the error of 0.05 again. So 0.05 plus 0.05 is 0.10 cm cube. The next thing we need to do is to talk about what a percentage error is. So we have already discussed that reading a Burette twice gives us an error of 0.10 centimeter cube. Suppose we measured a volume of 25 centimeter cube using our Burette. So the error of the reading would be 0.1, and the total volume would be 25 cm cube. So in order to calculate the percentage error in the Burette reading, we would calculate 0.10 cm cube upon 25.00 cm cube and multiply this by 100. This would give an error reading of 0.40%, which is quite less, making Burette highly accurate uh, measuring apparatus to measure variable volumes accurately. While using a Burette, if we measure a volume of, let's suppose, 12.80 centimeter cube, and it is said that the Burette was read twice, of course, initial and final. So both readings had errors, and the error would be plus minus 0.05 cm cube for each reading. So in total, the error would be 0.10. So the question would say that the final volume measured was accurate, as in 12.80. However, the initial and the final volumes that were taken using the Burette both had errors, but the final value did not have any error. How is that possible? So this was possible because the initial reading may have an error of plus 0.05 centimeter cube, and the final reading may have an error of minus 0.05 centimeter cube, and in this way the error would cancel out when adding these two together. Or the error could be the exact opposite. The initial reading may have an error of minus 0.05 centimeter cube, and the final reading may have an error of plus 0.05 centimeter cube. So even in this way, when we sum up these errors together, we end up with a value of 0. So there would be no error in the final reading that we obtain when we subtract initial volume from the final volume. So in this way, a reading from a Burette may be accurate if both the readings, initial and final readings, have an error in of opposite sign, one having a positive sign, the other having a negative sign.